Okay, guys, so this is 5.1, and I'm starting Intro to Trig Inverses. This video is actually made as a makeup for those that weren't here and those that missed it, and then some of you that have seen it before. So I am going to go through this rather rapidly, so my apologies for how quick this will go. But let's get started. Okay, so the first thing we want to talk about with trig inverses is that we have an inverse sign. And I said to use graphing paper. I'm going to tell you that this thing is going to come out something like this. It will be somewhere, it's doing a zigzag. It's zigging and not zagging. Okay, somewhere in this ballpark, okay? If you will take the time to do it, you'll find out when this is reflected across the line. This is what it comes to. But when you go online and you type this in and say, well, let's find y equals sine inverse of -1, because that's what this is asking you to do. So if you go to a graphing calculator or Desmos, it will, if you do sine to the -1 of x, it won't give you this whole piece. What it does give you is a piece that gets cut off here to here. So what you get instead is this highlighted piece of information, because anything outside of that does not pass the vertical line test, and it's not a function. So when it says, what's the graph? Well, it's the sine function, the sine curve, but it doesn't make a function. So is the original graph a function? The answer is no. Why not? Because it fails the vertical line test. Fails the vertical line test. That's what VLT stands for, and I will use that a lot. Vertical, this is a butylism, by the way. Vertical line test. Okay. Is the inverse a function? The answer is no, because it fails the vertical line test. But this piece right here in red, this passes the vertical line test. Passes VLT. Okay? So now this one, why did it change? And the reason why it changes when you plug it into Desmos is so that it will pass the vertical line test. Just saying. All right, so moving on down. I'm doing this rather rapid. My apologies. The domain of this, okay, well, that's an interesting thing too. So the domain is going to be, all right, you've got to remember where this would open up before when we were graphing. When you were graphing before these functions that made these curves, whether it started up here or what, they went between -1 to +1. So the domain is -1 to +1. Because here the range was -1, +1. And the range in these, it's going to go to -pi over 2, whoops, -pi over 2 to +pi over 2. And it will include them. All right, so this is the only place, this is the principal value, and we will be talking a lot about principal values in this unit. Okay, so the principal values will hit between -pi over 2 and +pi over 2. All right, so if I shade that of where it's going to happen in this, here's -pi over 2 to +pi over 2. Thank you. And this is where that graph is going to happen. Well, if we look at it even further down on the unit circle, where do these principal values happen as well? Let me get to the right thing. The principals happen from -pi over 2 up to +pi over 2. And we're going to see this drawing over and over and over from the unit circle standpoint. We will not see it from the graph standpoint, but what's highlighted in yellow on the circle, what's highlighted in yellow on the graph are identical. Then we're going to look at the cosine values, And instead of reproducing those and flipping it, I'm going to save a little time here and I'm going to show you what they flip. When they flip it with a cosine, it's going to be a little different because of where this thing shows up. This is what's going to show up when we graph it, which shows up on the unit circle right here. Okay? Tangent is yet a little bit different, but kind of similar to sine. Okay, this is the full run of the tangent. And when they flip this, okay, when this gets flipped, it's going to look a lot similar to this. Unlike the cosine, both the sine and cosine, when you do their inverses, both of these look kind of like, okay, this zigzag thing happened. And we're going to cut off part of it. And what I highlighted is the part we're going to cut off. Over here, when you do this one, instead of looking like that, it's going to look like this. Okay? And where this went from negative pi over 2 to positive pi over 2, this is going to be how low it goes to negative pi over 2 up to how high it goes. But the thing is, it's hitting asymptotes because these are asymptotes. And if you didn't get to graph these, that's going to hurt you understanding that. But nonetheless, you can get it, that it's an asymptote there. So this is going up to pi over 2, negative pi over 2 to positive pi over 2. And you can see here, it was going 0 to pi. And it included these values, where here it does not include the values because it doesn't include them here. If it's not included here, it can't be included in these. Okay? So when I do this one and highlight this one in blue, it looks just like the sine. The only difference between this one and sine is that these are undefined. And so it's not included because the tangent here is undefined. And this right here is going to be your key. Now, with that said, I am going to skip to the bottom. All right, I'm skipping all of this because I just covered everything you needed to know. So when you do this one, you can use the chart or you can use the calculator values. I'm going to grab a calculator, and what you're going to hit on the calculator is you're going to do second sine, which you'll see is the sine to the negative 1 of 0.412. Enter. All right, that gives you 24. All I'm doing is putting it in a calculator, 24.3. Now, I'm in degrees, so I'm going to round this to the nearest whole number because of my class, I just want the nearest whole number. It tells me you know how to find it. So second one, cosine inverse of 0.812, enter, 36 degrees. It's 35.7, so this is 36 degrees. Sine inverse of 0.981, 79, and so on. What you're going to find out here is that it says domain error. And if it says domain error, that's because the sign has to end between -1 and +1, and 1.8 is outside of that. So that's why it says domain error. All right. So this is not going to have an answer. Arc cosine of 1. Can we do that one? Well, you hit second cosine of 1. It is equal to 0 because it was 1.0. So this worked. That checked out in the calculator. And this is the same thing as cosine inverse. It was at the first of the page that said arc cosine and arc sine, arc tangent. That's the same thing. So this is an equivalent of this, okay? Means the same thing. So I'm skipping all of the tangent stuff because I've kind of already showed you how that works. And you're also going to find out when you're doing arc tangents, there is no limit. Like you look at number 3 right here. And if you're going to do an inverse tangent, second tangent, whoops, hit the wrong one. Second tangent of 2.417, enter. I get 67.5. So this is 68 degrees. And you're like, wow, it didn't tell me domain error. Okay, what about arctangent or inverse tangent of 100? Surely that one's a problem. No, it's 89.4. 89 degrees, okay? So even though it's really huge, you're going to have values. Tangent is a little different because, or it's a lot different because you don't have, once you flip it, the domain is still all real numbers, which is very different. The range is not all real numbers, but the domain is all real numbers. So domain, these numbers can be anything for arctangent. All right, trying to scoot on down. I don't know why it's not letting me. Good grief. Oh, it's because I'm at the bottom of the page. Okay, so I'm going to stop this one and we're done for right now. And I'm going to go on to 5.2.